Hello, everyone. My name is Carlos Rangel, and with my teammate,
Andrés Garcia.
we're going to present you Learning with AI. Our main topic, continuity. Well, we use ChatGPT as our main AI, and we're going to show you step-by-step examples and mostly discontinuities. Okay, so for the first slide, learning objectives. What are the main learning objectives of this activity? Well, the first one, understand the concept of continuity in calculus. This defines continuity at a point and on an interval. The second one, identify and classify discontinuities. These distinguish between different types of discontinuities. We have three different main types. The first one, removable, jump, and infinite. And for the last one, use Gen AI to solve and analyze problems. um, Show how can AI solve limits that help determine continuity, explain piecewise functions and where to check continuity, and simulate classroom dialogue or Socratic questioning to encourage our critical thinking. Okay, so for our second slide, the initial prompt. Um, we established a conversation with ChatGPT, asking him if he can help us on the different types of discontinuities, because we are like a little confused, and if he can provide us two examples of each type, simple example and one more elaborated. And ChatGPT responds us with the three main types of discontinuities: removable, jump, and infinite. And well, for the first one, the removable discontinuity happens when a function has a hole at a point. That is, the function is undefined or mismatched at that point, but the limit exists. And it gives us two simple and one more elaborated example. For the second one, the jump. The jump happens when the left hand and right hand limits exist but are not equal. There's a jump between the two sides. And for the third and last one, well, this occurs when the function grows without bound to infinite or negative infinite near a point. And well, a quick summary of this. Uh, Basically, the function is missing a point or it is mismatched, but the limit exists. For the jump, there is a sudden change in the value. The left and right limits don't match. And for the infinite, the function grows without bound. It means the limit does not exist. All right, for better understanding and a clear process, we decided to ask ChatGPT if he could help us with an example of removable discontinuity and its step-by-step process. So our question was, can you give us an example of a removable discontinuity, explaining the step-by-step, please? And thank you, bro. So ChatGPT answer us so we can really see how and why the discontinuity happens. Okay, so now for our step-by-step explanation in a simple example. Let's take a look at the function. F of x equal x squared minus 9 divided by x minus 3. We're going to identify our step-by-step process. For the step 1, we need to identify the domain and check for problems. This is a rational function, and we know rational functions are undefined when the denominator is 0. So step 2, we try to simplify the function. First, we need to factor the numerator, x squared minus 9. It remains x minus 3 times x plus 1. So the function becomes f of x equal x minus 3 times x plus 1 divided by x minus 3. So we cancel out the x minus 3 terms. And for the step 3, we need to analyze the limit. So now let's find the limit as x approaches 3. Uh, so we need to substitute the 3 in the x. It remains 3 plus 1 equals 4. So what does this mean? This is the classic case of a removable discontinuity. There is a hole in the graph at x equals 3. The function behaves like the line f of x equal x plus 1, except at that one missing point. So as a conclusion, a removable discontinuity happens when a function is undefined at a point, but everything else around that point is fine. You can simplify the function and find that the limit exists. The function just forgot to include the value.
Now, some personal opinion. Can you reproduce this activity for other calculus topics? Why? If yes, illustrate the case. Is the role of the professor changing next to the AI implication in learning scenarios? This activity can absolutely be reproduced for other calculus topics. For instance, when learning about limits, AI can walk us through graphical approaches and algebraic simplifications, helping us understand how functions behave near a point. With derivatives, it applies rules like the product and chain rule, and illustrates how slopes change along a curve. And in optimization, AI visualizes constraints and objective functions to guide us towards maximum or minimum values. Limits. Give you an example. We have the limit of x going to 2, x squared minus 4 over x minus 2. Factoring the numerator gives us x minus 2, x plus 2. So we cancel out the x minus 2, leaving us with x plus 1. Subtracting the x equals 2, we find the limit is 4. The graph confirms this idea through the function is undefined at x equals 2. We see the value approaches 4 from both sides. This is a great example of how algebra and visual works together to make limits clear. As we give the second example of the derivatives, the problem is f of x equals 3x squared plus 1 times x minus 4. Using the product rule that ChatGPT has given us, we could use this formula to understand and expand the problem. On the graph, the green curve shows a original function, and on the orange one represents its derivative. Notice how the derivative tells us the slope or rate of change of the original function, at any point a key insight into how a function behaves across the domain. Now for the third example, optimization, a classic problem. A farmer wants to fence a rectangular field next to a river using 100 meters of fencing. Since one side is along the river, we only need to fence the two widths and one length. Let's define the width as x and the length as y, since the total fencing is 100 meters. We get x plus 2y equals 100. Solve for y, we get y equals 100 minus x over 2. Now let's write the area function. Area is length times width, so we do x times 100 minus x over 2. That will give us 100x minus x squared over 2. To maximize the area, we have to take the derivative of area x. The derivative would be 100 minus 2x over 2. Set the derivative of x to 0, and we get x equals 50. The graph confirms it. A downward opening parabola peaks right at x equals 50, showing the maximum area when the dimensions are 50 by 25 meters. Now, as we finish the presentation, I would like to answer the personal question. Is the role of a professor changing next to the AI implication in learning scenarios? As for the role of the professor, it's evolving, not fading. With AI handling repetitive explanations, professors can now focus on building critical thinking, clarifying deeper concepts, and offering a human support that learning still depends on. Thank you for listening to our presentation. Hope you like it.